Okay, so we are starting our sequence and exponential functions unit. Do we have our notes out, Don? So go get them. First of all, we need to know what is a sequence. A sequence is a list of numbers that often form a pattern. We have two different types of sequences that we are going to look at. Our first one is an arithmetic sequence. That's a sequence whose successive terms differ by the same non-zero number d. Now, what that means is you are adding or subtracting the same number from term to term. So you add or subtract the same number from term to term. Your arithmetic sequences are examples of linear functions. We just completed 2 units over linear functions. Okay? So this day of sequences is kind of going to bridge what we just completed to now the next function we're going to move on to. So arithmetic sequences are an example of linear functions. Okay? You add or subtract from one number to the next to get the next number in the sequence. Okay? Then we have geometric sequences. Geometric sequences are a sequence whose successive terms have the same ratio. So instead of adding and subtracting the same number from term to term, what do you think we're going to do here? Multiply and divide. So you multiply / divide, and you're never going to really see it written as a division problem because when you multiply by a fraction, that's really dividing, right? A fraction means divide. Okay, so multiply or divide the same number from term to term. And this is an example of exponential functions. We don't know anything about exponential functions yet, but this is what we are going to start doing next class, okay? So our arithmetic sequences are an example of linear functions, and our geometric sequences are examples of geometric is exponential functions, okay? So over here we have like this little key to help us know what each of these variables represent in our formulas, okay? F of 1. What does that look like that we've seen before? Y. Fancy Y, right? Do we remember what notation this is called? Starts with an F. Function notation. Good job. And normally it says F of X, so here it means X is 1. So F of 1 means your initial value or your first term's value. That's why it's F of 1, the first number in the sequence. Okay, so what if I had like F of 8? What would that mean? The 8th term in the sequence. Very good. Okay, so then this F of n minus 1, this is the previous term's value. So if I wanted to find like F of 8, F of n minus 1 would be what term? So that would be the 7th term. Okay, so F of n minus 1 means go back 1 term. Okay? N is your term number. D is the common difference. And that's in what type of sequence? Which of these over here? Which one has a D? Arithmetic, which is an example of a linear function. So arithmetic sequences have a D, a difference, meaning you're adding or subtracting, and then R is your common ratio. Which one has an R? Geometric. That's when you're multiplying. Donovan, do you have a pen? Thank you. Okay. Okay, so let's look at our 4 different types of formulas we're going to use. Okay, we have 2 different sequences, arithmetic and geometric, and then we have 2 different sequences, arithmetic and geometric. Within each of those sequences, there's 2 ways you can write your formula. Okay, there's 2 formulas. You have explicit formulas, and then you have recursive formulas. Okay, so your explicit arithmetic formula is f of n equals, and remember f of n is just a fancy y, equals f of 1. What's f of 1 mean? The first term's value, plus d. What's d mean? The common difference, so what you're adding or subtracting each time, times n. What's n? The term number minus 1. So n minus 1 means your previous term number. Okay? From this arithmetic explicit formula, you can tell me what f1 is. Okay? f1's right there. Okay? You can tell me what the common difference is. It's right there. Okay? So, we're going to look at an example. F of n equals 18 plus 3 times n minus 1. So I have 2 numbers here. I have an 18 and I have a 3. Okay? Well, the 18 is your constant out in front. So what's that mean? So f of 1 is 18. So that's your starting value. Okay? Then, where do I find my change? Your change is D. Where do I find my D? In front of the parentheses. So here your change is 3. So what that means is you're doing what each time? Well, remember, it's arithmetic, so you're adding and subtracting. What's your change? 3. So what are you adding and subtracting each time? 3. Okay? So my sequence would be 18, because that's your starting value, and then you would add 3 each time. So it would go 18, so 21, 24, 27, 30, 33, 36, 39, and thus forth. Okay? These are the 2 things you have to be able to identify. Your starting value, and then how you change from that starting value. If you're able to get those 2 things, you're able to continue your sequence. Okay? The next thing it's going to ask us is to find a specific value. So here it says find f of 8. So that 8 is your what? It's not your starting value. We're still using this. Your term number. So that's your n. Okay? So I'm going to use my formula, and I'm going to replace n with what? 8. So f of 8 equals 18 plus 3 times, not n, what am I replacing n with? 8 minus 1. Okay, so we can go to our calculator, and am I going to type in the left side? No, because that f of 8 is just a fancy y, right? Okay, so I'm just typing in the right side. 18 plus 3 parentheses 8 minus 1. And I get 39, meaning f of 8 equals 39. Okay, now again, could you have just done what we did initially and say we start at 18, add 3? So 18 is your first term, 21, 24, 27, 30, 33, 36, 39. Is my 8th term 39? Yes. Now, what if it said they'll find your 100th term, f of 100? Would you want to count out plus 3 100 times?
You can do, like, on the calculator, you can just do time.
Okay, so we can go to the calculator. Let's all go to y equals. Donovan. We're not going to do this today. Okay, go to your calculator. Can you put n's in the calculator, though? No, what variable must you put in? X. Okay, so again, the f of n just is your fancy y, so I don't put that in. So y equals, and I'm going to type in 18 plus 3 parentheses x minus 1. Well, I'm wanting a list of values because that's what a sequence is. A sequence is a list of numbers. So what's going to pull up my list of numbers? Second graph, your table. Okay, so let's look here. I have 2 columns, though. How do I know which one represents my numbers in my sequence?
Wait, how do you get to the table?
Second graph. See how above graph in blue it says table? So second, hit your blue button, then graph. Okay, we all good? So look, your x is your term number. Your y is the term value. So my first term is what?
18.
My second term is? My third term is? My fourth term is? Go down to your 8th term. 39. So there's 3 ways we were able to do this. Okay, do I care how you do it? No. Okay, we good with that? Okay, next one is your geometric explicit formula. Okay, this is f of n equals f of 1. What's that f of 1 mean again? Your starting value, your first term's value, times r. What's r? The change. And it's what you are doing what? Multiplying or dividing. Okay? Again, if you're dividing, it's going to be represented as a fraction. Okay? And then raised to the n is your term number, minus 1. Okay? So, looking at these 2 formulas, what's the difference? Here I'm doing what? Adding. Here, what am I doing? Multiplying. When you add, you are what form, though? What sequence? Arithmetic. You got it. Arithmetic. Okay, think AA. Arithmetic add. Okay? And then geometric is where you are multiplying. Okay? So looking here, we need to be able to identify our different values. What's the negative 5 represent? Your what? Your starting value. I start at negative 5. And then what does that 1/3 represent? The change. Am I getting bigger or smaller?
Smaller.
Think that's small, right? So I'm multiplying by a small number, so it's going to make it smaller. I'm multiplying by a number less than 1, so it's going to make it smaller. Okay? Are we good with identifying those 2 values? Okay. Now find the 8th term. What can I do? If I'm finding the 8th term, what am I going to replace n with? 8. So I'm going to do f of 8 equals negative 5 times 1/3 raised to the 8 minus 1. Okay, let's put this in the calculator. Negative 5 parentheses. Do it as a fraction instead of a 1 divided by 3. Okay, do it as a 1/3 because that way when you get your answer it will pop up as a fraction instead of a decimal. Raised to the 8 minus 1 power. We all doing this with me? So much of this unit, guys, is going to be, can you use your calculator? Okay, can you let your calculator help you? So I get f of 8 to be negative 5 over 2,187. That's a really small number.
Wait, where do you go to see the answer on the graph or on the?
So we're now going to do it on the table. Okay, we good with this? I typed it in under the calculate part.
Wait, so we don't have to simplify it or anything?
So your calculator gives you the simplified fraction. This number, 2,187, is not divisible by 5. So there's no common factor other than 1, so you can't simplify this fraction. Okay, so let's go to y equals, and I'm going to type in my rule. So negative 5 parentheses 1/3 raised to the x minus 1 power. Wait, Carrie? We doing this, Alice? Come on, guys. And when I go to my table, I'm going to go to 8. And again, if I don't use the division bar, if I use the fraction bar, it's going to give me a simplified fraction on my table. If I use the division bar to represent my 1/3, then it's going to give me a decimal, and then I have to worry about converting my decimal back to a fraction. Okay? We good? Guys, the explicit formulas are the easier formulas. Okay? You're able to see your starting value. You're able to see your change. You can type your explicit formulas always in the calculator. Okay? We like the explicit. Okay? Now, we are going to go to our recursive ones. What your recursive means is you have to know the previous term in order to get the next term. Okay? Notice both of these formulas have this f parentheses n minus 1. Okay? What does that mean? F of n minus 1 means your previous term's value. Up here, see how we wrote that on our table? Or underlined it on our table? F of n minus 1 means the previous term's value. You cannot use or do recursive formulas if you don't know the previous term's value. I have to tell you a value, okay, for you to calculate or extend the sequence, okay? Can you put your recursive in the calculator? No, okay, you cannot. So, do you see an f of 1 in your formula? No. So your starting value still is f of 1, but can you identify that from the formula? No, there's no f of 1 in the formula. That's why I don't like the recursive as much. Can you still find your d and your r? Yeah, the plus number is your d, making this what kind if we're adding d? What type of sequence? Arithmetic, very good. And then here we're multiplying by r, so that makes it geometric. Okay, so I have my formula. Can I find my starting value just looking at the formula?
Yeah.
Where is it?
Am I right? No. Oh, no.
You can't find your first term from the formula. I'm going to then have to tell you, and f of 1 equals 14. So what's f of 1? What's your starting value? 14. Okay. What am I adding or subtracting each time? Look at your formula. Look right here. What are you adding or subtracting each time? 6. So I'm subtracting 6 each time.
So it's negative. Oh,
Okay. So to find the 8th term, I cannot just plug a number into the formula, because if I plug in 8 to the formula, it'd be f of 8 minus 1, which is 7, f of 7 minus 6. Do I know the 7th term's value? No, I just know the first term's value. So the only way to do your recursive ones is you have to know your starting value and then continue the sequence and write it out. Okay? So where am I starting? 14. That's f of 1. And then I'm going to subtract 6. What's 14 minus 6?
8.
So that's your what term?
Next term.
But tell me a numeric, like a number. Well, 14 is your first term. 8's your second term, so I need to keep going because I want to know the 8th term. So I'm going to subtract 6 again. Where does that put me? 2. That's now your 1, 2, third term. I don't want my third term. I want my 8th term. So keep going, right, Alice? Minus 6. Where am I now? Negative 4. That's only your 4th term. I need to keep going. Minus 6. And where does that put me? Negative 10. Keep going. Negative 16. So this is 1, 2, 3, 4, 5. We're at our 6th term. We need to keep going. Minus 6 puts us at negative 22. Keep going, and we are at what? Negative 28. 1, 2, 3, 4, 5, 6, 7, 8. Do I now have my 8th term? Yes, so f of 8 is what? Negative 28. These cannot go in the calculator, guys. You could use the calculator to do minus 6, minus 6, minus 6, minus 6. But you cannot put it in the table. You cannot just plug the number into the formula and get a nice, pretty answer. You have to continue the sequence when it's recursive. How do you know you're recursive? You have that f of n minus 1. Do both of my explicit formulas have an n minus 1? Yeah, but do they have an f of n minus 1? No. So if you have the f of n minus 1, that makes it recursive, and you have to continue your sequence by hand. Okay? Do we see the difference? Bless you. We good? Okay, next one. What's my starting value? 4 is my starting value. What are you multiplying by each time? Negative 2, so that's your R. How do I know that this is geometric / I'm multiplying? It says, well, just looking at this, it says negative 2 times or multiplied by. Okay, that's how I know I'm going to be multiplying each time. So I'm starting at 4, and I'm going to multiply by negative 2. And what does that put me at? Negative 8. Well, that's only the second term. I want the 8th term. So times negative 2. What does that mean? Or what does that give me?
Wait, so you're doing 4 times negative 2?
Uh-huh. Your starting value, and then multiply by your change. And why am I multiplying? Because it says times in my formula because it's geometric. Times negative 2, and that gives me negative 32. Times negative 2, and that gives me positive 64. Times negative 2, negative 128. So let's see where we are. 1, 2, 3, 4, 5. We're at 6. I don't want to be at 6. I need to be at 8. So times negative 2, and that gives me 256. And then times negative 2, negative 512. 1, 2, 3, 4, 5, 6, 7, 8. Do I have my 8th term? Yes, so f of 8 equals negative 512. Good? Okay, before we go to the next page, I want us to look really quick at our formula chart. Notice this is different than the other formula charts you've had for previous units. For some reason, I have no clue, they do not put your sequence formulas or your exponential functions formulas on the star chart. That's why we made our own little formula chart that you'll get every day and you will be able to use on your test. However, unfortunately, are you going to be able to use this on the STAR test? No. Okay? So, whenever we're doing these, look at this every day you're in here when we're doing it, because the more times you look at it, the more times or more likely you are to remember it. Okay? Again, will you have this on your test for my class? Yes. Okay? So far we've gone over arithmetic and geometric sequences, and there's your 4 formulas. Okay? Don't worry about the bottom part yet. That's what we're going to do the rest of the unit. Okay? Good? Okay. Next page. What do I notice comparing this to my formulas here? Does it look exactly the same? No. That's what's also kind of difficult about our sequences, is they're not going to always give you your formula looking exactly the same. The two main things that we need to be able to identify is our starting value and your change, whether it's arithmetic or geometric. Okay? Arithmetic means you're multiplying. Arithmetic means you're adding and subtracting. Geometric means you're multiplying. Okay? So here, do I see a plus or minus sign? Yeah, I see a -4. So what would this make it?
Geometric.
Which one's multiplying? Which one's adding, subtracting? Arithmetic is, remember, arithmetic add, AA, arithmetic add. So am I adding or subtracting here? Yes, so that makes this arithmetic.
And you know if it says like.
If you see a plus or a minus sign, it's always arithmetic. Okay? Also, what does this look like, guys? That we just finished doing. Y equals what? Mx plus b. So this is linear, which makes it arithmetic. Okay? Linear functions are arithmetic. Okay? What key attributes can be determined? Okay? Think back to your linear functions. What was your move value? What was your change value? Or in your equation, what represented how you change from one term to the next? Your slope. So same thing here. What's my slope? 3. So that's your change, which for our sequences, for our arithmetic sequences, we use D. Okay, that's your change. Is my change positive or negative? Positive. So am I going to add or subtract? Add. I'm going to add 3 each time. Okay? So, I can't find my B value, or I can't find my f of 1, because it's not in the same form. See how these don't look exactly the same? So I can't just look at my formula and find the f of 1. I can't find my first term. But that's okay. I have my change. And also, I have a rule that I can then use to find my terms. It says find the first 4 terms. So I want to find f of 1. In order to find f of 1, what am I going to plug into my equation? But I want to find f of 1, so I'm going to plug in 1. Okay, because f of n, I replaced n with 1, so on the right side, also replace your n with 1. So 3 times 1 minus 4. What's 3 times 1? Minus 4? Negative 1. So then let's do f of 2. Well, f of 2, I'm going to replace n with 2. Donovan, pick up your pencil and do it. You're not even on the right page. Okay, so what's 3 times 2? So turn to the right page. 6. And what's 6 minus 4? Stop making a mess in the classroom. Okay, 2. Very good. Well, how did you get from -1 to 3, guys? Sorry, -1 to 2? Plus 3. Is that what we said our change is? Yeah. So now let's find f of 3. 3 times 3 minus 4. What's 3 times 3? Minus 4. Also, how do you get from 2 to 5? Plus 3. What do we think f of 4 is going to be? Let's see if we're right. Three times 4 is minus 4, 8. So my sequence is -1, comma 2, comma 5, comma 8. Then it says, what is the 23rd term? In order to find the 23rd term, what would I do? Do you want to add 323 times? I don't. Can I use my formula? Yeah. If I'm finding the 23rd term, what does that mean that 23 represents? What variable? Your n. So I can use my formula and replace n with 23. Alice, do you have a pencil? Are we writing this with me? So I get f of 23 equals what? What is it? 65. Is this recursive? Do you see that f of n minus 1? Is there an f of n minus 1 in the formula? So could I have gone to y equals and just put it in y equals and pull it up? Yes. If it doesn't have an f of n minus 1, you can just use your table on your calculator. Okay? So how do we feel about maybe doing it for this one? Okay, let's look at our formula again, though. Is this one going to be geometric or arithmetic? Geometric, because I'm multiplying. So this is geometric. So let's look at our geometric formulas. Which one does it look like? Does it have that f of n minus 1 in it? Do you see an f of n minus 1? I see an n minus 1, but does it have the f in front of it? No. So it's this one. Okay? Do you see how these look almost identical, guys? Can I find my f1 and my r? F1's out in front. What's the number out in front? 6. That's your f1. Okay. Then your r is what's being raised to the exponent. What's being raised to the exponent? 5. So r is 5. I can find my first term and how I'm changing. Okay? Again, can I just use my calculator here? Yeah, because this is not recursive. So let's go to our calculator, go to y equals, and type it in exactly as you see it, except for the fact that you need to use an x instead of an n. Again, guys, your calculator will help you so much this unit. I don't know why we're not all using our calculator. That's poor choices. If you can use your calculator, this test should be a breeze. Almost all of it can be done on the calculator. So let's go to y equals and put our formula in. 6 parentheses 5 raised to the x minus 1 power. If it's asking for the first 4 terms, I'm going to start at 1. What's my first term? Well, it already told me in the formula. So 6, and then what comes next? My second term is 30. When we're looking at our table on our calculator, are we looking at our x's or our y's? Y's. 150, and then 750. Then it says find f of 8. So f of 8 equals 468,750. So, did I show you how to do it by hand? On the last one, did I show you how to do it by hand? Can you also just use your calculator if it's not recursive? Yes. Do we like using the calculator more? Saves us a lot of time, right? Okay, next one. What type of sequence is this? Geometric, because I have multiplication raised to a power. I have multiplication raised to a power, so that is geometric. When you are geometric, is this recursive or explicit? Do you see the f of n minus 1? No, so it is explicit. Okay? When it's explicit, you can find your f1 and your r. What's my f1? What's my r? Can we go to our calculator, put the equation in, and pull up the table? I would. So go to y equals. Again, make sure you type it in as a fraction. Here, Miles. Hands on the calculator, please. Come on. Ava, we awake? No, you're not. Okay, go to the table. Well, again, we should already know our first term. What's our first term? 1,024. Okay, what's term 2? 512. What's our third term? 256. And our fourth term is 128. Then it says find f of 10. So f of 10. Where am I going to scroll on my calculator to find that value? Where x is 10. So go to where x is 10. When x is 10, what's y? Good? How do we feel about our explicit? Again, if you don't have an f of n minus 1, then you can put it in the calculator. Just make sure you're using the variable x instead of whatever variable's in the problem. Okay? Good? Now we're going to move on to our recursive ones. Okay? So let's look at our two recursive. Okay, your arithmetic has a what? A plus d. Could also be a minus, okay? Plus or minus. Your geometric, you are multiplying, r times. Both of them have that f of n minus 1. Okay? So, f of n minus 1. In this case, do I even have an f? What letter are they using instead? T. Okay, what I say is cover up your t n minus 1. Cover it up. What am I doing with that 3? Am I adding that 3 or multiplying that 3? Multiplying. If you're multiplying, you are geometric. So this is geometric. Caden, sit up. So it is geometric. What key attributes can be determined? You can't ever find your f of 1 from a recursive formula. Okay, I have to actually give it to you. So in the formula, I cannot find my f of 1. However, what does that 3 represent? So the, what variable? The r. Very good. Okay, so it says find the next 4 terms, or what are the next 4 terms? So I'm starting at term 8 being what? 2. So I'm starting at 2. And what am I going to do with that 2? To find the next term. Times 3. Times 3. So I get what? Okay, what do I do with that number? Times 3. And I'm at 18. Then what do I do with that? And what am I at? What is it? 54. Okay, I have 4 terms. Should I stop? What's the question say? The next 4 terms. I had this term, so that's not included. So the next 4 terms, I only have 1, 2, 3 terms. So I need to do it one more time. And I get what? 162. So my sequence is 6, 18, 54, 162. Can you use your calculator if you have a recursive formula? I mean, you can to calculate it, but you can't put it in y equals, okay? Next one. Get the f out. Cover up your f of n minus 1. It's recursive. Get the f out. Cover up your f of n minus 1. What am I left with? A plus 4. So is this arithmetic or geometric? Because arithmetic means add, okay? So this is arithmetic. Again, from the formula, all we can find is R or RD. Do we have an R or a D value in arithmetic sequences? We have a D. What's my D? 4, positive 4. So it says, what are the next 4 terms? So it has to tell me a starting point. Where am I starting? What's my starting value they're giving me? 18. So what am I going to do with that? Add 4, and I'm at 22. Then add 4, and I'm at, then add 4, and I'm at, then add 4, and I'm at 34. So I have 22, 26, 30, 34. Good? Okay, last one of these, guys. Are we arithmetic or geometric? Why? We're multiplying by a half. Very good. It's recursive because I see my f of n minus 1. Now again, it's f of x minus 1. But that's the same as f of n minus 1. They could put any variable there. So it is geometric because we're multiplying by a half. Meaning that half is your what? What value? That is your R. Okay, what are the next 4 terms? Well, where am I starting? At 4. F of 6 is 4. Very good. And then what am I going to do to continue? Times a half. Harry, wake up. So what's half of 4? What's half of 2? What's half of 1? 1/2. Don't use decimals. And then what's half of a half? 1/4. So our sequence is 2, 1, a half, and 1/4. We multiplied because it's geometric. Okay? How are we feeling about these, guys? Not too bad? Okay. We have 4 more problems and we're done. Okay? The hardest thing about these sequences, like I said at the beginning, is they can change the way the formula looks. Okay? We did our recursive formulas as this f of n minus 1. F of n minus 1. Okay? And also we did our explicit as f of n, f of n. Look at these answer choices. Okay, a of n, a of n. Have we seen something that looks like this? No, we've only done it in function notation. That's okay. All of these also just mean f of n. This is another way of writing a y equals. Okay. Do I see a subscript n minus 1 or an f parentheses n minus 1? So all of these are what kind of formulas? Think about the 2 that either has the f of n minus 1 or doesn't. So look at your formula chart. Which ones have the f of n minus 1? The recursive. So are these recursive? Do you see the f of n minus 1 or the a subscript n minus 1? No. So these are all explicit. Okay? So, a good thing for us to start with is we need to determine how we're getting from one term to the next. Okay? What's happening with your -4 to get to -16? Multiply by what? Well, what's -4 times -4? Positive 16. So I'm not multiplying by -4. I'm multiplying by +4. How do you get from -16 to -64? Multiply by 4. How do you get from -64 to -256? Multiply by 4. So I am multiplying by 4. So my R is 4. If we're multiplying, what kind of function is this? Geometric. Okay, we already said it's not recursive. So let's look at our explicit geometric. I should have an exponent. Okay? Do you see how your geometric formula has an exponent? Does your arithmetic have an exponent? No. So look here. Which of these have your variable in the exponent? B and D. So I know it's definitely not A or C. Are these recursive? You see the A of n minus 1 or the F of n minus 1? No. So can I put these in the calculator and pull up the table? That's what I would do. So negative parentheses 4 raised to the x power. And then go to the table. Is my first term 1? Is my second term 16? Then 64, 256, sorry, and I should be saying negative. Negative 1,024, negative 4,096. So what's my correct answer? B. Good? If these are multiple choice, guys, okay, process of elimination. Narrow down your answers as you're going, okay? The next one says a sequence can be generated by using the equation shown where a of 1 equals 5 and n is a whole number greater than 1. You have your sequence or your formula and it says what are the first 4 terms of the sequence. Okay, so it's saying the first 4 terms. Well, here it says a of 1. That means my first number in my sequence is what? 5. So which answer choices can I get rid of? A and C. A and C don't start at 5. Okay? So just knowing A of 1 means your first term's value, I now have a 50-50 shot. Okay? Now we need to extend our sequence. Okay? That A subscript n minus 1, that's like your F of n minus 1. Okay? So get the F out. What am I doing? Each time. Subtracting what? 3. So that means my D is negative 3. So I'm going to do minus 3. And where does that put me? 2.
Wait, so 5 minus 3?
Uh-huh.
At 4 times?
Well, only 3 times because it already gave me my first. So 2 minus 3. And then negative 1 minus 3. Negative 4. You went 1 too far. Okay, so what's my answer? B. Done. Good? Now, guys, I will tell you, I think sequences are very frustrating because I can't give you one formula that always works. Okay, they can change these formulas to be using different letters. Instead of F of n, they're using A subscript n. Instead of F of n minus 1, they use A subscript n minus 1. Okay, so you need to know that anytime you see that parentheses n minus 1, that means you have what kind of formula? Recursive. And recursive means you can't use your calculator. You have to identify your D or your R, your multiplier or your adder / subtractor, and then you have to continue it by hand, okay? They're never going to ask you, if they give you the first term, they're not going to ask you for the 100th term in recursive, okay? Okay. Which formula best represents the pattern shown on the picture? Good thing to do would be to make a table, okay? I'm going to make a XY table. Donovan, 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 Donovan. Go outside. Go outside. Go outside. Okay, so this is my first term, second term, third term, fourth term. So 1, 2, 3, 4. We good with that? How many boxes are in my first term? How many little cubes? 16. How many are in my second? 8. How many are in my third? How many are in my fourth? 2. Okay, so am I subtracting by the same thing each time?
No, or the last one.
So let's think. How do you get from 16 to 8 by subtracting? Minus 8. 8 minus 8 would be 0, but this isn't 0. Okay, so this is not arithmetic because you're not subtracting the same number each time. Harry, what'd you say?
Divided by 2.
So what's 16 divided by 2? 8. What's 8 divided by 2? What's 4 divided by 2? 2. So this is geometric. And what's your R?
2.
Well, you're dividing by 2, so dividing by 2 is the same as multiplying by 1/2.
It's not B or F.
So it's definitely not B or F. B or D. B or D. Definitely not B or D. Okay, they don't have an R equal to 1/2. Also, these are what type? These both look like what type of function? Linear, which is arithmetic. Okay, and we do not have an arithmetic because we have an R value, not a D value. Okay, well, where am I starting? If we look at our geometric explicit, it's f of 1 times r raised to the n minus 1. That f of 1 means your first term's value. My first term's value is 16. Which of these has a first term of 16? A. Also, do you see an f of n minus 1? No, I see an n minus 1, but that's not the same as f of n minus 1. Can we put this in our calculator? Yes, go to y equals 16 parentheses 1/2 raised to the x minus 1. Then what should I do? Go to the table, and my table should match this. 116, 2, 8, 3, 4, 4, 2. Good? Okay. A sequence is defined by f of 1 equals 27 and f of n equals 1/3 f of n minus 1 for each whole number n where n is greater than 1. What is the first 4 terms of the sequence? Okay, so it's wanting the first 4 terms. What does it tell me at the very beginning of my problem? My starting value is 27. So what are my answer choices I can get rid of? Again, do you see how just knowing little pieces of the information we're able to eliminate answer choices? So I know I start at 27. Okay? Do I see an f of n minus 1? Yeah, get the f out. And what am I left with? 1/3. Am I multiplying by that or adding that? Multiplying. So is this an R or a D? This is an R. R is 1/3. Making this what type of formula? Or sequence? Geometric. So what am I going to do with that 27? Times 1/3. You cannot use your calculator, guys, for ones that are recursive. If you see that f of n minus 1, you can't type it in your y equals. You can use your calculator to multiply 1/3. Okay, so what's 27 times 1/3? 9. What's 9 times 1/3? 3. What's 3 times a third?
1.
So what's my correct answer? A. Good?
So,
All done. Okay?